Hi, this is Uday. I am a solution designer and also trainer in my organization. In this course, I will start by explaining programming concepts and will explain you the core concepts in Java. We will go through how to create desktop applications at enterprise level and also how to integrate them with different technologies like .NET and also with different databases along with cloud technologies. So what is programming? It is a set of instructions for the computer. It is the way we need to communicate with computer for doing any activities or calculations. A set of multiple programs collectively which are related to each other in functionality is called a software. For example, let's take photo viewer in Windows. Its task is to display pictures. It has multiple options available with it. We can copy a file, delete it, check the properties, email it, burn to a CD, print, etc. For each and every option, there will be a separate code written to it. All these programs are collected together and form this application footer viewer. The computer can understand only binary language, means 1, 0. All these instructions are provided to it in this machine language only. So whatever program we wrote, they are ultimately converted to machine language only. This converted code is called machine code. The programs we wrote in a normal English language are called as high level languages. So these high level languages are converted to machine code. Coming to the high level languages, it has three different types. We can see in this picture: procedural programming, modular programming, and object oriented programming. Object oriented programming is the most commonly used programming techniques used currently. Let's begin with procedural programming. In this procedural programming, functions are building blocks. What is this function? The logic we wrote in this programming are generally collated to a set of blocks called functions for reusability. Suppose if I wrote a particular logic around 10 lines and I want to reuse it again in some other execution phase, then I will use the same block of code by referring to it. Coming to the modular programming, it is similar to procedural programming, but in procedural programming, even though we are reusing our code through functions, all the code we are writing is in a single file. But in modular programming, we can divide the files into modules and each module contains some separate functions. At the end, we can merge all these modules to a single code. Coming to object oriented programming, the main problem with procedural or modular programming, complete emphasis is based on the logic of the code. But in object oriented programming, the importance is given to the real world objects. Let's say if I am creating an application. In procedural programming or modular programming, we'll think about the logic and we'll start writing the logic in a sequence phase, one after the other, what steps should be done. But in object oriented programming, we'll analyze what are the things we need to do. In procedural programming, we give importance to logic than the data we are doing the calculations. In object oriented programming, we'll give the importance to data and logic is given secondary importance. In object oriented programming, we interrelate real world entities appearing in the solution we are going to design for a problem, and we will accomplish the tasks by writing logic as interaction between these objects. In this way, distance between the suggested real world problem and our code is minimum and looks more related and also requires less logic. One of the reason is Java is a language suited for network, especially internet. Interconnection of computers is called a network. A network may contain two or more computers connected with a cable or without a cable. C++ is also an object-oriented programming language. But why Java is famous? For example, you can connect a computer in Delhi to one placed in Hyderabad, which are almost 2500 kilometers away, with the help of satellite, and data can be sent or received via satellite in the form of electromagnetic waves. So, a network layer may not have a cable. The primary purpose of a network is resource sharing, which means A computer can share its resources like data, memory, software, hardware, etc. with other computer on the network. In the network, one computer may ask the other computer for some service. The computer which requests for some service is called client, and the other computer which provides the service to the client is called server. A network can have several clients and several servers, and such a network architecture is called as client server architecture. Now let's say we are creating an application which need to be utilized in this client server architecture. Java suits best in this scenario. To convert our code written in any high level language like C to a machine code, we need some softwares called compilers. Suppose we are writing a program in C language, let's say x.c. This x.c file contains our source code. When we compile it to machine code, the x.obj file will get generated. In C language, we have a concept called header files. Like stdao.h is a standard header file in C language which contains all the functions related to standard input and output, like reading from the keyboard, writing to a monitor, etc. These are available to the C programmer by default by the compiler for code reusability. When we run the program, C compiler goes to the C standard library and searches for the header file stdio.h, etc. Once the header file is found, C compiler copies the entire code in the machine language format. So if you write a C program of 10 lines, the machine language code will contain 200 lines. C compiler copies the entire code. This code will be machine language format from the header file to the C program. So if you write a C program of 10 lines and the header file contains 200 lines, our machine code will have 210 lines. The file is also called x.exe. Once it is, the logic from x.obj and the header files are completely combined to x.exe, which is our executable code. Problem here is the final executable code we got with C language is machine dependent. It's dependent on the processor on which the code is compiled. Suppose if I write my code in C language and compiled in a Pentium processor, it won't run on an AMD processor. For that particular processor, again I need to convert to the machine code which it supports. This problem is solved in our programming language Java. In Java, our source code is saved to a file name with extension .java. So this x.java contains the source code we wrote. In Java, instead of compiling our source code written in x.java to a machine dependent code like in C language x.c, we are compiling to an intermediate language x.class, which is also called as bytecode, and this bytecode will be executed by the software given by Java called Java Virtual Machine, which is available in most of the machines where we want to deploy our complete product. So instead of compiling our code individually for each and every processor, we'll compile once to bytecode which will be executed by our Java virtual machine. So wherever this Java virtual machine is available, our program will be executed there. So because of this, the machine independency came into existence. We can write Java program once and compile it to bytecode. Then we can execute this bytecode in a number of machines with different architectures if the JVM is installed there. So what is this JVM doing actually? In general, conversion of source code to machine code is of two types. One is compilation. That one will completely convert to machine code. Another one is Instead of converting it, it will interpret the code written by us at the runtime line by line. It's moreover like executing the code directly instead of compiling them. The Java compiler, it consists of two parts. First one is compiler. It will convert Java code to bytecode, and then onwards it will use the interpreter called JVM to interpret this code to the machine. Thanks for listening to my session. In the next session, I will explain you how to set up the lab environment and execute the Java programs in it. Thank you.